Before we talk about geometric sequences and series, I want you to try this warm-up. So you get a job with a starting salary of $70,000, and it gets a cost of living increase of 1% every year. We want to know how much are you going to make in the second year and the third year. So in the second year, you would get the initial $70,000 plus 1% of $70,000. And we actually usually don't write it out this long. We usually write it as 70,000 times 1 plus 0.01, or as 70,000 times 1.01, and it does end up being 70,700. The third year is going to be same idea. You are going to take what you got from the second year, and you're also going to be multiplying that by 1.01. So I'm going to show you two different ways of writing this. So you get 70,700, you multiply that by 1.01, and you do end up getting another a little bit more money. You get $71,407 now. The other way that you can actually write this is as your initial value 70,000 times 1.01 to the second power. That's the same thing as what you just did. You're welcome to try that on your calculator and just make sure that it gives you the same answer. Or you could just trust me that it does, or just look at how you calculated out these two things and you'll see that it does end up giving you that. This type of problem is using what we call a geometric sequence. And a geometric sequence is one where you get the next term by multiplying by the same thing. So in this case, you would be multiplying each amount by 1.01, which is 101%. So I wrote out the definition here. Keep in mind that you multiply each term by the same number. That number that you're multiplying by is what we call the common ratio. And we represent that using the letter R. So the formula for the nth term of this, a sub n, is going to be your first term times the common ratio to the n minus 1 power. So you don't need to write this next thing down, but in case you're wondering for the warm-up, your first term was 70,000. Your common ratio was 1.01. You would have done that to the n minus 1. So for example, for the second year, that would be your A2. You took 70,000 and you multiplied by 1.01 to the 2 minus 1, which is to the first power. For the third year, you took 70,000 and you multiplied by 1.01 to the second power, which is 3 minus 1. So you did actually use that formula. So here's a few examples for you. You're welcome to try them all on your own and then kind of fast forward through if you want to. For number 1, you are going to list your first 5 terms. First one's given to us. Then each term after that, you are going to be multiplying by 1/3. They're going to get smaller and smaller. So 18 times 1/3, or 18 divided by 3, is going to be 6. Then we get 2. Then we get 2/3. Then we get 2/9. Then we get 2/27. So if you have something where you are, rather than multiplying by successive terms, you're actually dividing by successive terms, it's actually the same thing. It's just that it's multiplying by a fraction. So now I find my nth term by using the formula. Remember again, the nth term is actually your formula. That's what it's going for. It's going to be a sub n is equal to 18 times 1/3 to the n minus 1 power. For number 2, You just kind of need to see what your common ratio is. You'll notice that each of these is being multiplied by 5. So this one's really, the first part of this one's really easy because the first 5 terms are almost listed. You just need to get the fifth one, the first 4 are listed. And you will find that your fifth term is actually 1,250. You just multiply by 5 to get there. So that's already done. You just need to now write your formula. You get a sub n is equal to 2 times 5 to the n minus 1 power. And if you aren't sure if your formula is right, you're always welcome to go back and just choose like a random value. Let's say we decided to choose the third term just to make sure that we wanted to check your answer. You don't need to write this down, but it's just a nice thing to know. If you were to evaluate this formula, hopefully you would get 50, and we do. So that's one way that you can check your answer if you're not 100% sure that you're doing these right. For number 3, this one, it's actually a lot easier than it might seem. You have the second and third term. Basically, you'll notice that to get from the second term to the third term, you just multiply by 2. So that's your common ratio is going to be 2. So our first term would have been 2. Fourth term is going to be 16. Fifth term is 32. Same idea for writing the formula. You get a sub n is equal to your starting term of 2 times your common ratio, which is also 2, to the n minus 1. Now we're going to talk about finding sums. And this word series, I'm not sure if I've mentioned it before. If I have not, though, I'd like to mention that a series is a sum of a sequence. We're going to have 2 types of series when we work with geometric, which is going to be really interesting. The first type is going to be a finite series, meaning that it has an ending value. The second is going to be an infinite. We'll talk about that in just a minute. So before I give you the formula, I just want to make sure you understand this notation. This S sub n means the sum of n, the number of terms being n. This thing right here means we're going to take the sum from 1 all the way up to n. And this right here is my formula. You'll notice that I replace the n in the formula with an I. The I is called my index, and that's actually going to change based on what number I'm on. So first it'll start with I equals 1, then I equals 2, then I equals 3, and so on. The n is going to be the number of terms. This is not quite the same thing as what I was talking about before when I was talking about the nth term, because occasionally you'll replace n with a specific number. In this case, n is just going to be the number of terms, though. So my formula is going to be my first term times 1 minus r to n. Remember, n is number of terms, all over 1 minus r. And as I mentioned before, we are going to be also finding the sum of an infinite geometric series. This is not going to work every time. Sometimes you will have infinite series that have no sum. Sometimes you will have infinite series that do have a sum. And we usually write this as S with a subscript of the infinity sign. In case you've never seen that, that means infinity. Looks kind of like a sideways 8, but it's not a sideways 8, it's infinity. So S sub infinity, or my infinite sum, is going to be equal to the sum from 1 to infinity. Obviously, you are not going to be writing down 1 to infinity. You're never going to find the answer for that one. And then you will be using the same formula. That's my notation. So we also have another way of writing this notation out, and it's going to depend on the way that the formula you are given is written. I do, however, want to point out that actually these two things are exactly the same thing. The only difference is that I plug in as R2, my first term is R2, uses R to the 0 power in this one, whereas in the previous one, my first term used R to the 1 minus 1. It's the same thing. So the formula for this is going to be my first term, A1, all over 1 minus R. Formula for this is actually very nice. It's a simple formula for a really complicated concept. This is not going to be true. You're not going to be able to find this every time. It's only going to work if your value of R is between 0 and 1. Remember, R is, I'll give an example where R is, you don't need to write this, but I just want to make sure that you know. So if R is between 0 and 1, that's when you have something like, I think the example I gave you before was, I had 1/3. So if you have like 18, then you multiply 18 by 1/3, you get 6, and then 2, and then, so that was one of the examples I gave you. The numbers kept getting smaller and smaller and smaller. You are able to find a sum of that. We call that a converging sequence because the numbers get smaller. The other type of situation that you're going to have is going to be when your ratio is bigger than 1. So let's say you start off with like 2, and then 4, and then 8. You keep multiplying by 2, and you just keep getting bigger and bigger and bigger. When you keep getting bigger and bigger and bigger, that means that you are you're not going to actually be able to find a sum. You're just going to get these humongous numbers that you will keep adding together. So I will write this down. This is what we call a converging sequence, and this is what we call a diverging sequence. This is most likely not going to come up on a test or a quiz, but you probably will hear these terms in future classes, especially if you take more calculus classes. So let's do some examples. For these problems, I just asked you to evaluate the sum of the geometric series. For number 4, this is a finite series. We know that it's finite because they told us n equals 8. So I'm going to use that finite series formula. It's going to be S sub n is equal to A1 times 1 minus r to the n over 1 minus r. And this one's really nice because I actually gave you the values. Go ahead, calculate that on your own. So you should end up getting 1 times negative 255 over negative 1, which just gives you 255. By the way, you'll notice in this, I didn't write the summation formula. You can write the summation formula in the middle if you want to. If you did do that, you would have this like middle part where you had I equals 1 to 8 of 1 times 2 to the n, or the I, sorry, not n, the I minus 1 power. That's not necessary. You can write it if it helps you. The main reason I gave you that part of the formula was for cases where you have something like number 5. So for number 5, we know our a sub n is equal to 3. We know our r is negative 2. And we know our n value is 5. You're going to use the same formula that we just got. You get 3 times 1 minus negative 2 to the 5th power, all over 1 minus negative 2, and you do get a sum of 33. 6 is the hard one. You can see that there are 3 dots at the end. That is a sign that this is an infinite series. So we do need to use the infinite series formula, and what we're going to do, we know what A1 it is 27. You need to figure out, how do you get from A1 to A2? That I think is one of the harder things. We know that to get from the first term to the second term, you're going to be multiplying by a common ratio. So we can do 27 times r is going to be equal to 18. If you do that, you figure out that your ratio is 2/3. So I now have my ratio, I have my A1. You do not need to write out the summation formula. You're just going to use the final formula, which is A1 over 1 minus R. So that's going to give us 27 over 1 minus 2/3. And if you do that, you get 27 over 1/3, which multiplies together to give you 81.